Hello everybody, thank you for watching this. My name is Chad Heffernan. I'm the inventor of the Eclipse valve. This is a design of control valve that I believe is going to be revolutionary in the market. Specifically, what I'm going to talk to you about today is how it can compare to existing valve designs, more specifically globe valves, and how I believe that this can revolutionize anywhere where we're using globe valves for precise flow control. So with that, I'm going to go ahead and get started. So the problem inherent in globe valves, number one is that even though it's the standard for regulating pressure and flow very precisely, the problem is you've got a very turbulent flow path to start with. So when that fluid or gas comes in to one end, you see that it's going to be turbulently spun around, and you'll see oftentimes on the inside of globe valves that have been used in a number of years, especially if they have some kind of particulate in them, cavitation and noise and issues like that, vibration, can actually cause damage, not just to the valve itself, but you can see it downstream of the valve in the interior walls of the piping. The means of actuating a globe valve are also expensive and very difficult. You either need a linear actuator or a multi-turn actuator. In this case, this hand wheel requires several cranks to be able to land it in the perfect spot. Now, that's not necessarily a big issue unless you consider the fact that these actuators are very expensive and they have to be large and require a lot of torque if you want to automate them. And the biggest problem, I think, is that you have a large pressure drop from P1 to P2. That means that the size of the piping that you have has got to compensate for the pressure drop that you anticipate from P1 to P2 within a globe valve. So here is the direct comparison. With a 1-inch Eclipse valve, it has the same amount of flow as a 4-inch globe valve. So if you have both of them open fully, one, you've got a 4-inch pipe going into the globe valve. With the Eclipse valve, you have a 1-inch pipe going in and coming out. So notably, you're going to have a much smaller skid, much smaller piping, and much less expense in controlling the flow. Now, if we're looking at this to scale, this is literally to scale what a 1-inch Eclipse valve would look like next to a 4-inch globe valve. The performance would be nearly identical. Not only that, you'll also see that the size of the actuator is not that large compared to the size of the actuator on the globe valve. Now, so that we know that the dollar amount for an Eclipse valve is not going to equate to what you see with a globe valve. Obviously, the expense of manufacturing, the amount of materials, the aforementioned cost to actuate the valve is certainly much higher than it would be with an Eclipse valve. The other thing is, let's talk about the size of the piping. Now, not only is the size of the piping smaller, which would mean that your entire P&ID would be more compact, but the expense of materials would be much less as well. So you would need 1-inch piping as opposed to 4-inch piping, because you wouldn't have that anticipated pressure drop from P1 to P2 and have to compensate for it in your P&ID. Now, we also know weight-wise, when you're dealing with maritime applications, when you're dealing with shipping, we know that a 4-inch globe valve can weigh upwards of a couple of 100 pounds or more with actuation. The Eclipse valve would weigh significantly less and can be made out of a variety of materials: aluminum, bronze, hastelloy, incolloy, whatever the application would demand, but certainly would be much lower in weight than the globe valve would be. And now the biggest thing is the size of just the two flow control devices side by side. Again, this is a direct comparison of the actuator that would be required for an Eclipse valve with very low torque, can be automated very easily, versus a scale comparison to this pneumatic actuator, linear actuator, pancake actuator that you see here with the globe valve. Now, we also know size. It's been mentioned a couple of times. I think that is probably going to be one of the biggest savings that potential customers will have with this. Saving in shipping, saving in size of the entire flow, and then also saving in costs for installation and maintenance based on the difference in size. Now, let's talk about how I arrived at this design. I'm shortly going to show you how this works, but I was looking at a cigar cutter one day and I said, you know, if I could just actuate this with a 90-degree actuator, this would make the perfect valve. for a couple of reasons. One, it opens full bore. And two, it also directs the flow to the center of the piping, where the flow is more laminar, and it also keeps any cavitation and bubbling away from the interior walls of the piping downstream of the valve. Now, I had spent a number of years working with some of the world's largest companies dealing with flow control, 3M and Chevron and Anadarko and Boeing, and I've worked in various applications with flow control. Specifically with a design that was meant to do exactly what the Eclipse valve does. Now, everybody had a very big interest in it because of the compact factor, but cost was often a factor. So I was wondering, how do I take something so simple and make it inexpensive to manufacture while still being a high-performing valve? So the additional requirement that I had when I was coming up with this idea is that it's got to be inline serviceable. I don't want a valve that has to be taken out of service and taken off the line to be able to rebuild it or replace elastomers or replace obturator plates or anything like that. So that had to be a key function of the design of the Eclipse valve. So I got started. I taught myself how to do 3D design and got myself a 3D printer and started working on different prototypes. I actually went through 57 different prototypes before I had one that had the perfect amount of work. And by that I mean it worked smoothly, it had the perfect 90-degree actuation, and I could print it all up in one. This took about 2 days to print each one of these and then get it into send it out to customers as prototype to see if there was any interest. Now here's how it works. If I'm looking at the inner workings of the Eclipse valve from the top, it's very simple. There are 3 moving parts. There's a drive gear and then 2 plates that have a gear rack on them. And it's pretty simple. When you turn the drive gear 90 degrees, it slides these plates across each other. Now what's great about this is a couple things. It enables me to have metal seating. So in high temperature, low temperature applications, you can actually have pretty good shut off with just metal seating. And here's how. I incorporated a small incline in each one of these gear racks. And in that manner, when the valve is closing, it's actually pushing those plates up against the interior wall of the body of the valve. And so you have a flat surface, meaning a flat surface, and being pushed against it to enhance your shut-off capabilities. Now, you could also further enhance this if you wanted to put an O-ring on the interior wall of the body of the valve, and that would certainly enhance its shut-off capability. But I wanted this to have implications in applications such as steam or heavy chemicals or high pressures that elastomers can't see, or temperatures that go beyond what you would have with CalRes. And so that was incorporated into the design to enhance its shut-off capability. I also have a continuation in process that will be announced publicly very soon that does a lot more to enhance its shut-off capability, but that will be at a later date. All right, so if I'm looking at this from the front, again, if you keep in mind those inner workings of the valve from the top, here we are looking at it from the view of the fluid that's about to go through the valve. And as those plates slide against each other, they are opening and closing the valve, just like the cigar cutter I showed you earlier. So this goes full bore, precisely controls anywhere all the way to a full stop. Again, this 1-inch can replace a 4-inch globe valve and still have the same performance capabilities. Now, if we're looking at it from the view with the body in place, you can see how this works. Now, again, I wanted 2 opposing plates because we want to direct the flow to the center of the valve and of the piping to keep away cavitation, put it in a more laminar flow, and also enhance its performance capabilities, predictive, controllable flow of gases and fluids. So with that, I went out and I had some drawings made. So I literally have files that can be loaded directly into a CNC machine and have a full metal prototype built so that it can be put into testing with whatever application you can think of. And in that way, I can just email you something and we can go under an NDA or we can go under a commercialization agreement, and you can actually put this into a real life situation or on a flow loop and see how it does. So what I also had done was a CFD analysis. Now I know that most valves, when they want precise flow control, they're going to need something that's not just very smooth linearly with no jumps, no dips, but also something very logarithmic, because most people want the most control between 0 and 50% opening. So that is, I'm very happy to see that the CFD analysis came up with this. This is the CV curve from 0 to 100% open. You can see that from 10% on to 50%, there are very small increments in control. And that enables you to have more precise manufacturing when we're dealing with chemicals. Also has better regulation of pressure for things like boiler feed water systems, for gas well injection. Now, this is what makes it different though. The 1-inch Eclipse valve is right here. It's about the size of your fist. So you can imagine on a line where you've got a 4-inch globe valve, replacing it with this would be a significant improvement in the size. You can mount an actuator with a standard ISO 5211 pad, and that would allow you to use an inexpensive 90-degree actuator as opposed to a large pneumatic pancake or linear or multi-turn actuator. So you're saving money on the actuation as well. Now, the also simple ability of this to be a low cost to manufacture. These 6 bolts are all I need to assemble an Eclipse valve. So you can cut, you can do investment castings with some final finish machining, which would be very inexpensive. And then you put these 6 bolts on and you have your valve completely assembled. What makes this nice too is that it is inline serviceable. So it takes about less than a minute to remove these 6 bolts, pull your inner workings out, replace your plates and your drive gear, and you're off and running again. You just have to shut down your line for a minute or so, throw your new plates in, and you're up and running again. You can't do that with typical globe valves, ball valves, gate valves. You're going to end up having to spend a lot more time when you get those wear surfaces done. All right, so let's talk about next steps. Now, I mentioned that I have a continuation in process for a new version of the design, basically accomplishing the same thing. However, I'm enhancing the shutoff capability. So if we think about the rangeability of existing valves, this will be the most rangeable valve on the planet. So you think about things like pilot plants, where it's extremely important to have a lower scale full production model of, say, oil and gas refinery. And now you're going to be able to more precisely simulate those experiments on your pilot plant that are going to translate more readily to your oil refinery. You can see in these pictures here, I've got a couple of concepts too. One thing I was wondering about is, okay, what about cryo? What about extreme temperatures? And if we wanted to do that, the only thing we would have to do is elongate the body of the valve so that the seals that are inside of your of your pinion shaft are further away from the harsher environments of the line. So if you're doing cryo or high temperatures, that would be the way to get around that. You could even do things like, let's machine in some heat sinks on the body of valve, and then that way the temperature at the top of the valve where the pinion meets the seal there at the valve top stays away from the extreme temperatures. I've also come up with a way to eradicate the gear rack. So if there were, say, a severe service like, say, precipitated calcium carbonate with paper manufacturing, you could get away from having the gears in place and use a slotted design like this. Now, it would accomplish the same thing, but the fear of dirt or grit wearing down the gear set is much lower. And then you can see in the top right here, we also have the ability to characterize these plates. If you need a specific type of flow, you could just machine in a chamfer and have different characterizations of flow for each Eclipse valve. And again, it would just be a matter of replacing the plates. So if there were, if the initial plates don't work, let's switch them out for these and get a more characteristic flow that we're looking for. So I have the SolidWorks files for a 1-inch and a 2-inch. So that's what I'm starting out with. I think those are going to be the most popular sizes to get out to the market. And then I'm going to need some help with adapting a stem and seal design added. So I'm not just looking for an investment partner. I'm looking for a partner to help me bring this to market and help take over the flow control industry by working with me, and let's adapt the design to be more of a full mass production design. So I would allow under NDA the production of this valve and the addition of it onto a flow control loop for your own testing and using it for your own purposes. I don't require any commitment for that, but I do recommend it. I'm working with several different companies right now doing that exact same thing. They're putting their own proprietary seals on it, and they're putting it on their flow loop, and they're seeing what kind of attributes the valve has. It's going very well. So I would recommend that you work with me on a commercialization agreement before getting into testing. Now, I'm also doing something a little different than most people doing. Now, I would prefer to have a holistic license for one company. So if that's you, I'm most interested in going that direction. However, I understand that not everybody interested in a new flow control technology does everything, right? So there are some companies that are in chemicals, there are some companies in aerospace, there are some companies in oil and gas. And so for that reason and that reason alone, I'm also offering this as, if you have a specific application or industry that you're interested in using this this valve for, you're welcome to go ahead and let's talk about commercializing it just for that industry, and then that way you're only getting a partial license for that patent while I continue to sell it to other industries that use it in other manners. So it would protect your industry, your application, while I continue to go and find other applications for it that are unrelated to yours. So with that, I hope if you have any questions, you'll reach out to me directly. My phone number is 786-280-2082. I really appreciate you guys joining me for the last 17 minutes. If you have any questions, please reach out to me. Thanks so much.